measures of central tendency. Measures of central tendency. Now, today that would be our last topic on that particular measures of central tendency. And there are two other terms or other topics. The first one is called the geometric mean. And another one, that one is called the harmonic mean. Now, before that two means, another one was previously discussed, that one was arithmetic mean. Now, those are particularly coming from the series, that is the first one, arithmetic series. Second one is called the geometric series or progression, and the third one from the harmonic progression. Now, already some of you already known the fact that what is the meaning of arithmetic progression or arithmetic series, geometric or harmonic thing. Just once again, I am discussing about that arithmetic series or arithmetic progression is practically based on the plus and minus. That means, suppose some number or some series is starting from 0, then we are adding 2 with that. So the second term would be 2, another 2, that is 4, another 2, that is 6, 8. That means each and every time we are adding 2 to that particular numbers. As the plus is involved here, so that one is called the arithmetic progression. And from here, we can find the arithmetic mean. Another one, suppose if we consider the minus, that means suppose some series is starting from 5, then minus 1, so that is becoming 4, minus 1, that is becoming 3, minus 1, that is becoming 2, 1, 0, minus 1. That means what is happening here? Each and every time from the previous term, it is minus 1. That one is called, that plus 2 or minus 1 are practically known as the common difference. And from that common difference, when that one is involved, plus or minus, that type of thing is arithmetic progression. And from here, we can find out the arithmetic mean also. Next one is called the geometric progression or the geometric series. That means here, in the case of geometric progression, the multiplication and division, these two operators are involved. Like some series is starting from 1, then the next one is 2, then the next one is 4, then 8, then 16, then 32, then 64 only. That means what is happening? Into 2, into 2, into 2, into 2, into 2, into 2. So in that case, the multiplication is involved. Another one series, suppose we are thinking starting from 1. Here we are dividing by 2. So the next one is half. Another one we are dividing by 2. So it is becoming 1 by 4. Another one dividing by half or multiplication by half. So it is dividing by, then 1 by 8, 1 by 16, 1 by 32, like that. Suppose here what we are doing, dividing by 2 or multiplication by half. Both are giving half. Then again dividing by 2 or multiplication by half, giving us 1 by 4. So in that way, whatever these terms we are getting, that means when the multiplication and the division are connected with that particular thing, is called the geometric progression or the geometric series. As like in the arithmetic progression, this type of thing, plus 2, plus minus things are known as common difference. In that case, those are known as common ratio. So the first one is the arithmetic progression, second one is the geometric progression. Third one is called the harmonic progression or the harmonic series. Okay, in that case, the arithmetic progression is involved. That means, suppose we have a number starting at 1, then the reciprocals, that means the denominators, would be in AP. That means, suppose 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7. If we look at the denominators, the denominators are in AP. Because if we think at the first denominator, that is 2, then the second denominator 3, then the third denominator 4, fourth denominator 5, sixth denominator 7. In that way, what is happening? Plus 1, plus 1, plus 1, plus 1, plus 1. So that is giving us the harmonic series or harmonic progression. Suppose another one we are thinking here. Suppose that one starting from 1 by 3. Then the next one, 1 by 1. Then the next one, 1 by minus 1. 1 by minus 3. 1 by minus 5. That means what is happening? The denominators. Look at the denominators. That type of series, 3, then 1, then minus 1, then minus 3, then minus 5. Those are practically connected with that one thing, minus 2, minus 2, minus 2. So the first one is connected with the arithmetic progression, the normal one. Then the geometric progression connected with the multiplication and division. Arithmetic progression is based on the plus and minus or subtraction sign. And the final one, harmonic series or harmonic progression, is based on the arithmetic progression, but the denominators only. Okay, our topic, the first one today, is called the geometric mean. So the first one is the geometric mean. Already the arithmetic mean for the central tendency already discussed. So what is the geometric mean? Practically, we can say or we can define as the at the nth root of the product of n numbers or datas, whatever we say. Suppose we have two numbers we have. That one is 2, another one, suppose not 2, suppose I am thinking 4, another one, suppose 16. So what we can find out, how we can find out the geometric mean? Just look at the definition, nth root of the product of n numbers. Here, n is equal to 2. That means two numbers are involved. Then, product of n numbers. So that means we have to multiply 4 into 16. Then, find out the nth root. Here, that should be second root. That means that is practically the square root, because only two numbers are involved here. That is the square root. So that means square root of 64, or that is plus 8. At that moment, I am writing not minus 8. I am writing plus 8. As it was only two numbers, that's why plus 8. Suppose there are three numbers. So three numbers means let it, those are 2, 4, 8. So when we have three numbers, that means we have to find out cube root of 2 cross 4 cross 8. Now, you already know that the cube root of that particular number, that means 864. Now, cube root of 64 is different. We have to find out another way. If there are not three numbers, suppose 10 numbers are there. So that means we have to find out the 10th root of x1 into x2 into x3 into x4. Those are the numbers x5 up to x10. So that is some hefty condition. If the numbers are more than 10 also, more than 3 also, that is also an hefty or calculative thing. In that case, we can use the logarithm. That means another way, or practically the main way to find out the geometric mean using logarithm. Geometric mean using logarithm. Now, some of you don't have any idea on logarithm. But if you have the calculator, it's a scientific calculator, you can find out how we can use the logarithm to find out the geometric mean for that particular numbers or digits. That may be written as log of GM. That means what should be our geometric mean is equal to summation of log of xi divided by the total number of elements or data, that n total number of data. So if we have 2, 4, 8, then we can find out the log of GM of that particular three numbers is equal to summation of log xi. That means x1, x2, x3. Summation means the first one we have to find out the log of 2. Then we have to find out the log of 4. Then we have to find out the log of 8. Then divided by, as there are three numbers, 1, 2, 3, divided by 3. Now, using calculator or any other way, log table, we can find out the value of log 2. That is 0.3010 plus then log of 4, that is 0.6021 plus 0.9031, that is the value of log of 8 divided by 3. So that gives us the value total after summation, that is 1.8062 divided by 3. That one is equal to 0.60206. Now that is not the end, because we have to find out the geometric mean, not the logarithm of the geometric mean. So for the geometric mean, we have to find out the antilog of that particular value. So we can write antilog of 0.60206. And once again, using the scientific calculator or any other way of the log table, you can find out the value. And antilog of that particular value is equal to 4. Now, once again, you can check here that 3 cube root of 64, that means is cube root of 8 into 8. That means 2 into 4 into 8. So we can write 2 into 4 into 8 as cube root of 2 into 4 into 2 into 4. So that one is equal to cube root of 4 into 4 into 4. That means 4. But when there are 3 numbers only, that is possible. When there are 4 numbers only, we can factorize again. We can proceed. But if there are so many number of elements or datas, it is not always possible to factorize in that way and we can find out the cube root. Then there is the better way to use the logarithm to find out the geometric mean. And once again, that is based on the ungrouped data. That means whatever we have found out here, that is based on the ungrouped data, not the group data. Okay. And if there are different weighted type, weighted ungrouped, weighted ungrouped data, then that is also possible using the formula, that is log of GM is equal to the first one weight, that is F1 or the frequency, then the value log of X1 plus then F2 of log of X2 plus up to the Nth, that is Fn log of Xn, divided by the total number of elements. Now total number of elements means using on the frequencies, total number of frequency. So that is F1 plus F2 plus F3 up to plus Fn. So in that way we can find out, or we can write down the formula as summation of Fi with log of Xi divided by summation of Fi. So that is the normal way we can find out. Most of the cases, weighted ungrouped data we cannot, normally not use. For the unweighted ungrouped data, we normally don't use the geometric mean. In that case, we can use the arithmetic mean, but that is the way. Then use the GM. That means after that, we can use the GM and we can use the anti-log of that particular Fi divided by summation of Xi. Up to that, is that clear?
Yes, sir.
Okay. Next one, normally where we use the geometric mean, because arithmetic mean, okay, some real life examples are there where the geometric means are mainly used, and very important terms or aspects are there for the geometric mean. Most suitable places, most suitable areas, we can also say. The number one, that is averaging, we should check here, averaging rates of changes. Number two, that is very important in every type of financial conditions, the compound interest formula. That means in bank, the geometric mean is used. Then the discounting. That means most of the cases in the financial aspects or the capitalizations, the geometric mean is very important. Suppose the first one, averaging rates of changes. Some problem based on that. Suppose the question is like that. A person has invested rupees 5,000 in the stock market. Then at the end of the first year, the amount grown to rupees 6,250. Although at that moment from the current position, uh, real life position, that is impossible, but suppose that is at the end of the first year the amount grown to rupees 6,250. So practically he has a 25% profit. Then if at the end of second year, and the end of second year, his principal has grown to rupees 8,750. The rate of increase is 40% for that particular year, for that year, not 25% in the second year also, but in the second year, the 40%. So question is, what is the average rate of increase? So that means for the 2 years, what he has gained with the rate of increase, and that we have to find out the average of his investment. Now anyone can think that investments occur in the question during 2 years. So someone can think, sir, it may be 25 plus 40 divided by 2. No, we cannot proceed in that way. That is not the average rate of interest. In that case, we have to use the geometric mean. And how? So that is the solution for the first year. That means we can find out the geometric mean, that is square root of 1.25 into 1.40. Let's check what is happening. Suppose if I give 1 for the first year, only 1 rupee, then I am getting 25% increase. So after 1 year, I am getting 1.25. Like if I give the 100 rupees, then I am getting 125 rupees. In that way, the person has given the 5,000 rupees. So he is gaining the 6,250 or 1.25. Okay. Next one, the 1.25 is here. At the end of second year, his principal has grown to 8,750. That means 40%. So suppose for the second year, that is 40%. So if someone is giving 1 rupee, then he is getting 1.40, or 100 rupees he is getting 140. So in that way, when he is giving 6,250, he is getting 8,750. So that one is the 1.25 into 1.40. After multiplication, we are getting 1.75, or after square root, we are getting 1.323. So the average rate of increase in the value of investment is therefore whatever we have found, 1.323. 1.323 minus 1 or 0.323, and which is then multiplied by 100 to get the correct value. So gives the rate of interest as 32.3%. So that means 25% in the first year, in the second year 40%. So after that, the rate of interest for the after 2 years, that is 33.3%. So in that case, we can use the geometric mean. Sorry, একটু interrupt হলো. So in that way, we can find out the first one, averaging rates of changes using the geometric mean. The second one, the compound interest formula. Practically, from that particular problem, also we can find out the compound interest formula. That means from the above problem, we can also find the compound interest formula. That is 1.25 into 1.40, which gives us 1.75. And if we want to write that 1.75, that would be discussed today after some time, but I am just writing here 1.25. That can be written as 1 plus 0.323 whole square. That means let P2, that means after second year, the principal amount, that is 1.75. Then P0 at the start, the principal amount was 1. Then R, the rate of interest, is equal to 0.323. That one, 0.323. So the above equation can be written using the compound interest formula as like. That means P2 is equal to 1 plus R whole square. That means P2 is equal to P0. That one was 1. So P0 into 1 plus R whole square. Practically, that one is called the compound interest formula also. Okay, so if we want to demonstrate it once again, here the first one, P0 was rupees 5,000. Then I am writing here. Okay, so we have P0. That one is equal to rupees 5,000 or simply 5,000. So what should be after n year? So principal amount after n year would be P0. That one into 1 plus 0.323 whole to the power n. As it is our second one, so we can write P2 is equal to 5,000 into 1 plus 0.323 whole square. That means 5,000 into 1.75, or that one is equal to rupees 8,750, or whatever we have already discussed in the problem. So that is our compound interest formula. That means Pn is equal to P0 into 1 plus R whole square. After that, we would proceed with another one thing. Okay, suppose we have a problem. The problem is like that an economy has grown at 5% in the first year, 6% in the second year, 4.5% in the third year, 3% in the fourth year, and 7.5% in the fifth year. Question is, what is the average rate of growth? That means each and every year you may check from the first year 5%, second year 6%, third year 4.5. So sometimes it is giving some extra or sometimes it is diminished. So what is the practical average rate of growth of the economy during the 5 years? So we have to construct a table at first, that would be better. So that one, so suppose that is the first one year, 1, 2, 3, 4, 5 years. Then the second column, that is rate of growth, that is using percentage sign. So in the first year that is 5, in the second year 6, then 4.5, then 3, then 7.5. Next one, value at the end of year X, and that is also in rupees. So when for the first year, if I submit 100 rupees, then I am getting 5 more. So that would be 105. Then in the second year, I am getting 106. In the third year, I am getting 104.5. Not the compound. Only simple, I am using 100 rupees in the third year. Then after third year, I am getting 100 plus 4.5 in that way. Then 103, then 107.5. We have to find out the log x here. And log of 105, that gives us the value 2.02119, then 2.02531, 2.01912, 2.01284, 2.03141. We have to find out the summation of all the logs. So log of x is equal to 10.10987. Already discussed, we can find out the log and find out the GM. So what is the geometric mean now? So already we have found that log x. So GM, at the first time I am writing directly. That means anti-log of summation of log x divided by n. Now we can find out the n. N means total 5 years. So anti-log of the value 10.10987 divided by 5, or anti-log of 2.02197 which gives the value 105.19. So the average rate of growth, that is for the 5 years, that one 105.19 minus 100 or 5.19. But already we have found all the things in percentage rate of growth. So there is no need to multiply it with the 100, because in the first problem, whatever we have done, suppose that in the first problem, whatever we have done, now we have used the 1. That's why we have to multiply it with 100. That means that one. But here already we have used the percentage sign and already we have used the 100. Look, check when that is for year 100, for 100 that is 105, for that is 100 plus 6. So that means no need to multiply it with 100. So for the growth of the 5 years, that is 5.19. So we can write it like that. The growth would have been 5.2% per annum. So in that way, we can use the geometric mean. And the second one, that means the first one was averaging rates of changes. The compound interest formula, the final one for the discounting, and that discounting is also coming from that particular formula here. That means if we want to use the discounting formula, that is also the use of geometric mean. Simply Pn is equal to P0 into 1 plus R whole to the power n. So we can write P0 as Pn upon 1 plus R whole to the power n. That is the normal expression. Suppose a real life example, there is a machine. There is a machine in some company. Now we know that machine can work for as long as 20 years only. So now that 20 years, for the 20 years, the net income is from that particular life of 20 years yield a net income of suppose rupees 50,000. Okay, and that is also per year. So the question is like that, at the end of 20 years, the machine would be obsolete. The machine is obsolete. So what is the machine's present value? The question is, what is the machine's present value? That is using the discount like. That means we can use in that way 50,000 for the first year, then 1 plus R whole to the power 1. Then for the second year, this year also the net income 50,000, then 1 plus R whole to the power 2. Then 50,000, then 1 plus R whole to the power 3. In that way, up to 20 years, that is 50,000 and 1 plus R whole to the power 20. That means for the 10 years. And that one is known as the value of future income. So the value of future income rate is practically known as discounting. Whatever the discount means, we think that is not true. The value of the future income rate is practically known as the discounting. So that is the geometric means. Once again, from the very first one, if there are the ungrouped type of data, we use the log normally. Then if there are other type of rate of interest thing, we can use the geometric mean. Now a very simple formula for the harmonic mean, the next topic. Very less scope for the harmonic mean, maybe in your syllabus, but how we can find out the harmonic mean? Just a way, that is n by the total number of, then 1 by 1 1 by x1 plus 1 by x2 plus 1 by x3 plus dot 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 1 by x to the power n, or simply the reciprocal of summation of 1 by x up to divided by n. And for the weighted, that is also called HM is equal to reciprocal of summation of, if that is weighted, I is equal to 1 to n, suppose fi into 1 by xi divided by, or that one can be written as n by summation of I is equal to 1 to n, then fi into 1 by xi. Let's check with one problem, that would be a better way. Suppose we have the observations. We have 3 observations or data, that is 4, 8, 16. We are required to calculate the harmonic mean. So reciprocals of 4, 8, 16 are, we can say 1 by 4, 1 by 8, 1 by 16 respectively. So HM is equal to, what is the meaning? We can find out HM is equal to n by 1 by x1, 1 by x2 plus 1 by x3. So that one is equal to how many data? That is 3. So 1 by 4 plus 1 by 8 plus 1 by 16, or 3 by 0.25 plus 0.125 plus 0.0625, or the final result near about 6.857. So in that way, we can find out the HM. Just another problem on HM, that would be better. Suppose the question, a series has been given, and that is based on class interval. So I am directly writing the table. Class interval, those are given 2 to 4, 4 to 6, 6 to 8, 8 to 10. And the frequencies are also given. That means that is 20, 40, 30, 10. Find out the mid value. Find out the mid value at first. 2 to 4, its mid value is 3. 4 to 6, mid value 5. 6 to 8, mid value 7. 8 to 10, mid value 9. So we have to find out the reciprocal of mid value. That means 1 by 3. That one is the mid value. 1 by 3, 0.3333. Then 1 by 5, that is 0.2000. 1 by 7, that one 0.1429. 1 by 9, that is 0.1111. So final one is fx upon fx into 1 by x. That means 20 into 0.3333. That one into that one. So that one gives us 6.6660. Then you may write it as f. It would be better for you only. Next one, 8.000. 40 into 0.2, that is that one. Suppose that next one, 4.2870, then 1.1111, and the complete result is 20.0641. So the harmonic mean is the reciprocal of summation of I is equal to 1 to n, that is fi into 1 by x upon n. So we have already reciprocal of summation means that is 20.0641, 20.0641 upon, if we consider the total f, summation of f, that one 20 plus 40, 60 plus 30, 90 plus 10, that is 100. So the result is here like reciprocal. So 100 should be as numerator and the denominator is 0641. That is nearly equal to 4.984. So that is the harmonic mean. Just one line we want to say for the geometric mean. There is a problem in the geometric mean. What is the? We can say a limitation. If there is any negative item, when we can say it as limitation of geometric mean, when there is a negative item in the series, or when there is a 1 in the series, or when there is a 0 value in the series, the geometric mean cannot be calculated. Just think here, if we have 3 data, that means 1 to 0. We cannot find out the geometric mean here because that one cube root of 1 into 2 into 0, that give us 0. 0th cube root, that is impossible case. When the data is 0 or 1, there is a problem. So in the other cases, the discounting or the average rate of growth or anything, geometric mean gives us a very precise and very perfect calculations.